Welcome to the class of microwave and radar engineering. This is lecture number 5 and here we will continue with the transmission line, and in the last lecture we have discussed about the reflection coefficient and the transmission coefficient. Now we will discuss about the standing wave ratio, and we will discuss some numericals based on the standing wave ratio and the earlier topics. So standing wave, what are the standing waves? Let's see. If I say this is a transmission line and incident wave is this one, that is denoted by V plus, and at the load when there is imperfect matching, when ZL is not equal to Z naught, then there will be imperfect matching, and due to imperfect matching there will be a reflection, that is V minus, which is denoted by the reflected voltage is denoted by the V minus, or reflected current I can say, that is denoted by the reflected this arrow. Clear? And this can also be known as the incident current. Now see, when this wave, incident wave, is like this one, and there is some standing wave. When there is a standing wave, when both wave have same phase, then there will be a maxima of the standing wave, and when the phase is of opposite, then there will be a minima of standing wave. Means there will be standing waves exist due to the superposition of incident wave and the reflected wave. Clear? Means standing wave exists when ZL, when there is imperfect matching and ZL is not equal to Z naught. Clear? And I can say that standing wave exists when there is superposition of incident wave and the reflected wave. Clear? Now see, this is V equal to V plus, this is a equation that is equal to V plus e की पावर में minus gamma z plus में superposition of standing wave, superposition of incident wave plus में reflected wave V minus e की पावर में gamma z, and gamma is equal to alpha plus में j beta. Clear? Now see this one, if I have put the value of gamma here, we will get V plus equal to e power minus alpha minus j beta z plus में V minus e power alpha z into में e power j beta. Now see, just put the value of e power minus j beta z and e power j beta z, you will get V plus equal to e power minus alpha z cos beta z minus b j into sin beta z, and here put e power j beta z equal to what? Cos beta z plus में j into में sin beta z. Now take the common part of cos beta z and take the common part of sin beta z. Now you will see that cos V plus e power minus alpha z plus में e power alpha z cos beta z minus j into में V plus e power minus alpha z minus of V minus e power alpha z sin beta z. Now see this one, at standing wave, this is standing wave equation, you can say this is standing wave equation. So Vs is generally given as EV naught e power minus j phi. On comparing this equation, let's say this is equation 1 and this is a standard pattern, that is equation number 2. You will observe that V naught will be what? Magnitude of, because this one is what? A plus में, this equation is in the form of A plus में j beta, yeah, A plus में jb, and magnitude of A plus jb is equal to what? A square plus में b square. So the magnitude, that is V naught, will be equal to what? Root of A square plus में b square, that is V plus में e का minus alpha z प्लस में v माइनस e इक्वल अल्फा जेड का स्क्वायर cos स्क्वायर बीटा जेड प्लस में v प्लस e इक्वल माइनस अल्फा जेड माइनस ऑफ v माइनस e इक्वल माइनस अल्फा जेड का होल स्क्वायर sin स्क्वायर बीटा जेड. Now the phase part will be what? In the equation this phase part will be what? Tan phi equal to what? Tan phi equal to what? B upon में a, or I can say phi equal to what? Tan inverse of b by a. Clear? So phase will be what? Tan inverse of, this is tan inverse of v plus e equal minus alpha z minus of v minus e equal alpha z upon में v plus e equal minus alpha z plus में reflected voltage equal alpha z tan beta z. Now see this one. Let's say this is a transmission line, this one is incident and this one is reflected. This one is source and here it is load. Let's say at the load, if I say z equal to 0 and at the input side, at the source side z equal to minus L when the transmission length is L. Clear? Now V equal to what? Incident voltage, reflected voltage Vi equal minus alpha z Vr. Now due to the mismatch there will be some reflection. I have already told you that mismatch occurs when ZL is not equal to Z0, or I can say when there is a imperfect matching. Clear? So at some point, if I say this is a incident wave and this one is reflected wave, at some point on the transmission line, because this is a superposition of incident voltage and the reflected voltage, at some point incident voltage and reflected voltage will be in the same phase. So at that instant, two voltage amplitude will be added and maximum amplitude will be obtained. When this wave and this wave have same phase, then there will be a addition of amplitude will be added. Clear? Now at some other points, the incident voltage and reflected voltage will also be the out of phase. So there will be a reflection, there will be a subtraction of two voltages. At that point, minima or minimum voltage will be obtained. So this one will be the standing wave. You will see here, this one is amplitude and this one is Z along Z transmission line. Clear? Now see, you will see this one, that though I have all show you that the amplitude will be same, but it is somewhere different. Clear? Now let's say if I say at this point the amplitude of the incident voltage and the reflected voltage will be same, phase will be same. At that point the maximum amplitude will be obtained, and at this point phase of the incident and voltage reflected voltage will be opposite, out of phase. At that point the minima will be obtained. Clear? Now see this one, Vmax will be equal to what? When there will be a plus addition of two amplitude of voltages amplitude, and minima when there is a subtraction of amplitude of two voltage. Now we will see here that this occurs when beta z equal to n pi. This shows us of same amplitude, same phase, when beta z equal to n pi, where n is the 0 plus minus 1 plus minus 2, and this equation will occur when beta z equal to 2n minus 1 into my pi by 2. Just put this value. You will see here that when beta z is equal to n pi, there will be addition, and when beta z equal to 2n minus 1 into my pi by 2, that is then we have subtraction. Clear? Now see, this third point is very important. The distance between the two successive maxima or minima is always the 1/2 of the wavelength. Means if I say this one is the standing wave and the distance between the two maxima is equal to the 1/2 the wavelength, that is lambda by 2. Clear? Or you can say, if I say this one magnitude, that will be known as the guided wavelength, lambda g divided by 2. Now the third point is, when the distance between the any two successive maxima or minima is 1/2 the wavelength. Let's say if I say this one is a standing wave, so this is maxima, first maxima, and this one is, I say, this is second maxima. So distance between the two maxima will be equal to lambda by 2. Or I can say that if I say this is a in microwave, so it will be equal to lambda g divided by 2. Lambda g is equal to, if I say this is a waveguide, clear? So in the waveguide, that is equal to 2 maximum, that is equal to lambda g divided by 2. So beta z equal to n pi. So just put this value one time, just put n equals to 1, another time you will just put n equals to 2, then you will say that z equal to n by z equal to lambda by 2. When you will put n equal to 1 time is equal to 1, and another time when you will just put n equals to 2, you will see that z is equal to lambda by 2. Or in generalized formula, just put this to beta equals to 2 pi by lambda, multiply with z equal to n pi, you will get z equal to n into my lambda by 2. Now see case 1, when incident voltage is not equal to 0 and reflected voltage is not equal to 0, then the standing wave pattern becomes equal to V naught V plus EQ minus alpha Z. Clear? And when incident voltage is equal to 0 and reflected voltage is not equal to 0, then only V naught equal to V output will be equal to V minus EQ or alpha Z. When both magnitude V plus and V minus both are equal, means when positive wave and negative wave have same amplitude, then V plus equal minus alpha Z equal to V minus equal minus alpha Z, and at that time Vs, that is source voltage with 0 phase difference, will be equal to twice of V plus equal minus alpha Z cos beta Z. Means you will see here that in this equation there will be addition. Clear? So Vs will come out to be twice of V plus equal minus alpha Z cos beta Z. So this one is the voltage standing waves. The distance between the two maxima will be lambda by 2 and distance between the two minima will be lambda by 2. Now what is standing wave ratio? Standing wave ratio is the ratio of the maximum voltage or the minimum voltage. Means if I say this is a standing wave pattern and this one has some amplitude, and this maxima has some amplitude. So ratio between the two maximum voltage and the minimum voltage, that shows the VSWR. That is, it results from simultaneous presence of wave traveling in opposite direction on transmission line. Clear? So VSWR equal to Vmax upon V minimum, or if I say this is in terms of current, then Imax upon I minimum. Clear? Now as we know that VSWR will be equal to 1 plus reflection coefficient upon 1 minus reflection coefficient, then reflection coefficient that comes out to be VSWR minus VSWR minus 1 upon VSWR plus 1. That is the reflection coefficient. Now see this one. For the case 1, I'll just say when reflection coefficient equal to 0, means there will be no reflection. When there will be no reflection, you will see here that S will be equal to what? S will be equal to, put the value of reflection coefficient equal to 0 when there is no reflection or you can say that there is a perfect matching. So S equal to will be what? Equal to 1. Clear? Now when there is a maximum reflection, the reflection coefficient will be maximum reflection. The reflection coefficient will be equal to 1. At that time you can say that S will be equal to what? 1 plus में 1 upon में 1 minus 1, that is equal to, that approaches to infinity. So you can say that the VSWR varies from 1 to infinity. Clear? Now next one is the numerical, that if I say this numerical is based on the transmission line equation. If I say this transmission line equation has following parameter, that is R equal to 2 ohm per meter, inductance is 8 nano Henry per meter, C equal to 0.5 millimho per meter, and C equal to 0.23 picofarad. So calculate the characteristic impedance and the propagation constant. Means we have to calculate the propagation constant, that is gamma, and characteristic impedance, that is Z0. Clear? Now as we know that Z0 equal to root of R plus में j omega L upon में j plus g upon में g plus j omega c, and put the value of R here, 2 ohm plus में j into में 2 pi f. F is 1 gigahertz, frequency equal to 1 gigahertz, that is equal to 10 to the power 9 hertz. Just put this value here and put the value, you will get the Z0 equal to 179.44 plus में j into में 226.5 ohm. And for the gamma equal to, as we know that the gamma equal to R plus में j omega into में g plus में j omega c, just put the value of R plus j omega L into में g plus में j omega c, you will get gamma. That comes out to be this one, 0.0151 plus में 0.273. Clear? Now next numerical is a transmission line has a characteristic impedance, means Z0 equals to given 75 plus 0.01 ohm, and is terminated in a load impedance, and load impedance is what? ZL equals to 70 plus में j 50 ohm. Compute the reflection coefficient and the transmission coefficient. As we know that the reflection coefficient is equal to what? ZL minus Z0 upon में ZL plus में Z0, and transmission coefficient is equal to what? Will be what? 2 into में ZL upon में ZL plus Z0. Clear? The reflection coefficient equal to ZL plus minus Z0. Just put this value here, and on solving this equation using calci, you will get 0.08 plus में j into में 0.32 ohm. And transmission coefficient is formula has, that is 2 into में ZL upon में ZL plus Z0. Put the value here and you will get, that is 1.08 plus में j into में 0.32. Now there are special cases of lossless terminated lines. First case is when ZL equal to 0, means this is a short circuiting. When ZL equal to 0, you will get reflection coefficient equal to -1 and VSWR equal to infinity, and input impedance comes out to be j into में J0 tan beta L. Case 2, this one is the voltage current waveform and the impedance variation along a short circuit transmission line. Second case, when ZL is equal to infinity. When ZL is infinity, reflection coefficient comes out to be 1, VSWR is infinite, and input impedance comes out to be minus j into में Z0 cot beta L. This one is the current and voltage along a open circuit transmission line. Third case, when there's two different, that is ZL here ZL and here Z naught. As I have told you, deflection coefficient ZL minus Z naught, transmission coefficient, and this one is the return loss, transmission loss. And at that time, when there is a perfect matching, Zn equal to ZL, you will get for transmission line Zn equals to Z naught का whole square multiply में ZL. The book I have referred for preparing the slide, that is Microwave Devices and Circuits by SM Lyo. Thank you.